question. For the reaction A to B, the following graph was obtained. The time required for the concentration of A to reduce to 2.5 grams per liter. Okay. He is asking the time required for the concentration of A to reduce 2.5 grams per liter. If the initial concentration of A was 50 grams per liter. Okay. So he given initial concentration, that is how much? So initial concentration A0 is equals to 50 grams per liter. Next, at time t, it is reduced to how much? 2.5 grams per liter. Okay, and he is asking what is the time. So now from this graph, for the reaction following graph was obtained. Okay, so he is not given which one, which order reaction it is, but from the graph here concentration of A and time. So the graph is like this. So from this graph we can say that this is a first order reaction, right? So for the first order reaction, K is equals to, what is the formula? For 2.303 divided by T log concentration of A0 by concentration of A at time t. So by substituting these values here to calculate T, we must know what is K. But is he mentioned here K value? No, he given only log 2 value, but K value is not given. So from where we can get that K value? From this graph. Okay. So from this graph what we can understand here? At time 5 seconds the concentration is how much? 40. At 10 seconds the concentration is 30. At 15 concentration 20. At 25 seconds the concentration is 10. Okay. So as the time passes the concentration of A decreases. Okay. So now we know that for a reaction at every stage the rate constant will be same, right? So now take any time difference. So now take the time difference 5 and 15, okay, which is easy to calculate. So 5, 15. What is the time difference here? We know that rate K is equals to change in concentration by change in time, right? So now what is the change in time here? 15 minus 5 is equals to 10. And what is the change in concentration at this time? At 5 seconds the concentration is 40 and at 15 seconds the concentration is 20. So now by using these values we can calculate K value, right? So K is equals to 2.303 by T log concentration of A0 by concentration of AT. So here 2.303 by T. What is the time difference here? 15 minus 5, that is equals to 10. So log initial concentration. So that means at 5 seconds concentration is how much? 40. And at 15 the concentration is how much? 20. If you want you can take 10 and 20 also. Okay, the difference 10 and 20. At 10 concentration 30, at 20 here not 20, 25. At 25 the concentration is 10. You can take that values also. Okay. So now 40 by 20. So now 2.303 by 10 log 21 jo 20, 2 jo 40, right? Log 2 value. So log 2 is equals to how much? 0.3010. 0.3010. So 2.303 into log 2 is equals to how much? 0.693, right? So 0.693 by 10. So K is equals to how much? 0.0693. So from this we got the rate constant 0.0693. Now substitute here. Then what you will get? 0.0693 is equals to 2.303 by T log concentration of A0 is equals to how much? 50 initial concentration. At time t is equals to how much? 2.5, right? So 25 1 ja 25 20 ja. So now send T to this side. T is equals to 2.303 divided by 0.0693 into log 20 means log 2 into 10, right? So log A into B equals to log A plus log B. So log 2 plus log 10. T is equals to 2.303 divided by 0.0693. If we place one more 0, these will get cancelled. So 693, 2.3030 into log 2 value is how much? Log 2 plus log 10. So log 10 value is equals to 1. Log 2 is equals to 0.3010, right? Shall I substitute here only? Log 2 value is equals to 0.3010 into log 10, plus log 10 value is equals to 1. So that is 1.3010. So 23030 into 1.3010 divided by 693. Simplify this. Simplify this. Here T is equals to 23030 divided by 693 into 1.3010. How much we will get? If you do this, approximately you will get 43.03 seconds. Given here, time is given in seconds, right? So seconds. Here for the reaction A to B, the following graph was obtained. The time required for the concentration of A to reduce to 2.5 grams per liter, nearest integer. He is asking the not exact value, he is asking nearest integer. So for 43.03, what is the nearest one? 43. So here answer is how much? 43. Okay. Here instead of doing this, here you can substitute directly. You can equate this equation to that and you will get the answer also. Okay. Next, which of the following statement is not true for radioactive decay? Okay, which is not true for radioactive decay? Half-life is ln 2 times of 1 by rate constant. Here we know that radioactive decay is the first order reaction, right? So for first order reaction, T half is equals to ln 2 times of K. So right, this is correct only. How can we write this? Ln 2 into 1 by K. Here ln 2 is equals to 2.303 into log 2, right? So 2.303 into log 2 value is 0.3010. So 2.303 into 1.3010, then how much will get? 0.693 divided by K. So 0.693 divided by K. So this is the correct one only. So this statement is correct. Half-life is ln 2 times of 1 by rate constant. Correct. Decay constant increases with increase in temperature. No. Actually, decay constant is independent of temperature. It does not change along with the temperature, right? So decay constant does not depend upon temperature is the correct statement. It increases along with increase in temperature is the wrong statement. Next, amount of radioactive substance remained after 3 half-lives is 1 by 8th of original amount. He is asking after 3 times. So after 3 times means 1 by 2 power 3. So that is equals to how much? 1 by 2 to the power of 3 T half. So that is equals to 1 by 8 times of initial T half. So that is also correct. After 3 half-lives, it is equals to half to the power of 3. So 1 by 2 to the power of 3, that is equals to 1 by 8 of its original half-life, original amount. So that is correct. Okay. So here, what is the question? Which of the following statement is not true? So here A, C, D are true, B is not true. So answer B. Here to calculate the remaining amount will be is equals to half to the power of n. Okay, how many half-lives here? 3 half-lives. The formula to calculate remaining amount will be equal to half to the power of n. Okay, remaining amount after n t times will be equals to 1 by 2 to the power of n is the formula. Okay, so here he is asking remaining amount after 3 half-lives. So after 3 half-lives, how many half-lives? 3. So 1 by 2 to the power of 3. Then you will get 1 by 2 to the power of 3, that is equals to 1 by 8 times of original amount.